Please go ahead.
I'll do the first part. Okay, so today we are going to present our project on the threat part of the Pintos project. And this is, this wording Pintos is, I would say it's just a mini simple operating system framework for us to add on or modify some functionality implementation. And actually it already have some functionalities like threads, virtual memory, file system, anything implemented, but simply versions. So we are going to focus more on the threads parts because it'll be a pretty large effort if we do all of them. So we are gonna add on three implementations, which are alarm clock, priority scheduling, and advanced scheduler. And we are gonna use the command line make check in the threads folder because this is already a full operating system file. So we are gonna use make check to get all of the test results. As you can see in this picture, we are having most of the tests filed because these are just checking if we have all these three mentioned implementation correctly, which of course not. And so finally, after all our implementation, we want to finally reach all these 27 tests pass. So that's what we are gonna do in all the following parts. Okay, so I'll cover the first two. The first one is the alarm clock. Actually, this one is having a working implementation in Pintos. It's just using a busy waits. It's pretty easy that it's just spins in a loop and monitor the current time. And when it waits until the time we want the threads to wake up, and we'll just exit that loop and wake up the thread. So that's just how we have already in the Pintos. But what we want to do is re-implement this function to get rid of this part. And how we do that is by the following step. We basically just first, when this function is called, we block the thread first, and we add a number called tickets blocked to record how long the thread has slept. And this number is decreased by 1 for each detection of one clock interrupt. And then once this number is decremented to 0, we wake up the thread. So that's how we implement in our code. And next is the priority scheduling. So this is the parts I would say most related to our lecture. So we are gonna solve the problem priority inversion by implementing priority donation. So priority donation is a easy understanding concept. It's just, let's consider we have 3 threads with high, medium, and low priority. Priority donation means, for example, the H is waiting for let's say a lock, the L is holding, but now medium comes. So this, if we don't do any priority donation, there won't be a way for us to execute high first. So that's why we let high to donate some of its property to L first. And this way we will get rid of the, solve the priority inversion problem. So, but within this concepts, there are plenty of different situations we need to consider. I've listed 2 most important ones. One is multiple donation, which is saying, for example, let's say we have both of the H and I are waiting for a lock that L is holding. So then L will keep the highest donation priority, which we are saying is the H1. And another situation is when we face nested donation. Nested donation just means H is waiting for lock L is holding, and M. And then M is waiting for something L is holding. So this way, both of the nested one, M and L, will hold the priority H once. So that's how we implement this priority donation part. Okay, I will just stop sharing. Let my groupmates to share his screen.
Okay, I will do the next part, and let me share my screen first. Can you see my screen?
Yes.
Okay. Okay, so our last new feature is advanced scheduler, which is a multi-level feedback queue scheduler essentially. It is inactive by default, and we can choose this scheduler with some command line option. And basically, this scheduler maintains several queues of threads, which are ready to run. And the threads in different queues has a different priority. And the scheduler will choose a thread from the highest priority non-empty queue. And if that queue contains multiple threads, and they will run in round-robin order. And the thread priority is dynamically determined, and the formula is given below. Here, the prime max and the nice are constant, and recent CPU measures the amount of CPU time a thread received recently, and the load average estimates the average number of threads which are ready to run over the last minute. And so we can see the key strategy here is that if a thread takes too much time, which means its recent CPU is very large, so its priority will decrease. So here is our demo for updating the load average and recent CPU. So the first demo is updating the load average for 60 threads, which spin in a loop, and it prints their load average value every 2 seconds. And here is the second demo. So the second demo is to update the load average as well as the recent CPU for a single thread. And we can see that the load average and recent CPU just increase with time. Okay, so next, here is our final result. After implement all the 3 features, it passed all the tests just mentioned before. And at last, I would like to summarize our project. Basically, our project is based on PintOS, which is a very basic operating system. And we add 3 new features about thread on it, which is alarm clock, priority scheduling, and an advanced scheduler. And there are also some feature work on it, such as user programmers, virtual memories, and more advanced features. And that's our presentation. Thank you for listening. Yeah, any questions?
Sure. My first question, I want to ask all 3 of you. This is like nothing technical, but I want to ask you why you picked this topic, Pintos. I not really familiar with Pintos. It looks like, I just checked Wikipedia. It's like a nachos. Is like I mean, from the Wikipedia it says it's like a simple, but it's an education operating system. So why you pick this topic? Is that because the work you're doing, or is because some other reason?
I think PintOS already has a very basic operating system, and it do have some related topic with our lecture. Just as Xingyue mentioned before, the priority inversion, and we have to solve that issue by write real code on that operating system. And
Right.
That will
No,
help us.
I understand. I mean, to me, that your alarm clock is basically convert a busy waiting solution to a non-busy waiting solution, which is, and the third one, when you talk about your scheduling, that is actually a very standard Unix scheduling in FreeBSD, this type of operating system. We have been using this scheduling policy about looking at the load, looking at the recent CPU cycle since probably around 1985. We're using that scheduling. So so the thing is that it's actually well known, but there is should be a particular reason that why. I mean, for example, Pinto must be really simple compared to other operating systems. Other operating systems more secure, so sorry, more mature. And Pinto is probably good for education operating system for instruction undergraduate course, which is fine. I'm just a little bit curious because they're not. I don't think are there any industry company are using Pintos in the real world project?
I would say probably no, because they are just I would say the functionality they have, I mean, in the original source codes are pretty simple, and that's why we are trying to do several, I would say, functionality improvements and also new functionality implementation.
Right.
So I would say no.
Yeah. So just to let you know, when you talk about priority donation, have you heard about a concept called lottery scheduling? Have you heard about a concept called lottery scheduling? If you do a search called lottery scheduling, so lottery scheduling is having what we call lottery tickets. You use a lottery ticket to compete for CPU cycle. And when we solve priority inversion problem, is the lottery ticket got donate to the thread or the process that's currently blocking the semaphore. So FreeBSD, that is my a typical undergraduate project to ask people to add the priority, not priority, I call it statistical priority inheritance, which is lottery scheduling. That's usually a pretty good undergraduate project that you can add it to FreeBSD. So it's related to priority donation, I think, based on the way I hear what you were saying. The only difference is that lottery scheduling is a probabilistic scheduling. So you have more ticket, that means your priority is not deterministic, but it's probabilistically that this is going to get the high priority task. So just let you know. Okay, so I really think that you mentioned there is a future work that you want to do. I don't know what user program, but I probably I know they don't have virtual memory that implemented. My question is really, why do we need that? Because we have a different educational operating system, and so typically we can teach an operating system as simple as Pintos, or I can teach operating system a little bit more real world features, because, for example, they don't even have a virtual memory. How do I actually teach virtual memory as a operating system concept using Pintos? So that's why I'm asking, I mean, if you think about that's the future work for do virtual memory, is that the only motivation is for you to have a instructional operating system, or is that there is any other reason? There are some real world project or your academic research that you would like to use Pintos in this scenario? I mean, I'm just asking, curious about your plan. So it's probably only the instruction. That's okay with me. I just want to get a better sense about what you guys are doing. Okay, yeah. So my comment to you is that I think it's a good educational. I mean, I appreciate your hard work that you get. The first time I saw I think that's a great one. Is the first one. I think there was a lot of failure in the test cases, but at the end, I think Zihao shows that you pass all 27 tests. So I think that's a great work that you're doing there. I just want to think about what will be the interesting next step. Okay, to be honest, I'm very familiar with the operating system kernel work, the formula you present. That's usually I'm very familiar with that. So I appreciate. I know it's interesting work that you're doing there. So may I ask, are all three of you PhD or master student?
Master.
Oh, so all three of you are master student?
Yeah.
Okay. Is it first year, second year?
First year.
First year?
Yeah, I'm first year.
Okay. Well, if you're second year, this is probably the first year you get on campus anyway. So welcome all three of you to UC Davis, and I just want to say, if you're interested to do this kind of kernel level programming, there's some work. You can ask me maybe after this week. I can probably give you some idea about some of the kernel hacking work that's actually is needed by the community that hasn't been implemented yet. Some of the more advanced concept of scheduling. There are certain problems with that scheduling policy that we have been using since about 1985. We need to have a newer way of doing scheduling. There's a concept, by the way, you're talking about the thread. There's a concept called user level thread scheduler and kernel level thread scheduler. And those two schedulers, they need to coordinate. And there is a concept called scheduler activation that's actually similar to the non-busy waiting stuff that you converted. It is also an old idea, but it has some interesting feature there you might want to consider. It's called scheduler activation. When you have a time, you can take a look at that. Okay, all right, thank you. I think that's fine with me now. I just very quickly try to ask you, you haven't done your homework 2, homework 3 demo with me, right?
Yeah.
Okay. So the TA is not here right now. So I will ask TA to post a schedule so you can show your homework 2 and homework 3 demo. Okay. And
Okay.
it should be really quick. I will make sure that have you finished your homework 2, homework 3 demo?
We have finished the homework 2 and 3, but I can show the demo here.
Well, no, I don't.
I haven't prepared for it.
Yeah. No, that's okay. We will schedule some other time very quick because I want to turn off the recording. I don't want to record the grading for homework 2, homework 3 here.
Yeah.
And so I will turn it off, and I will let TA post his availability so you guys can join. I mean, a lot of group already done it last week to do the homework 2, homework 3 demo, but we over office hours. So I'm not too worried. We don't have too many group left. So I want to make sure that you will get it done. It will be really quick. If I'm going to grade it, it's like 3 minutes is done. Okay. All right. Thank you for your hard work, and I hope you have a good spring break. And hopefully we will see each other in the spring quarter. Okay.
You too.
Okay.
Thank you.
Yeah.
Thank
Thank
you.
you,
Professor.
Thank you.